So this worksheet 4, is really divided up into two major concepts. The front side is all about the law of definite proportions, which is our success criteria right now, explaining the law of definite proportions. Remember I told you yesterday, this particular law, which we did this on notes. If you weren't here, you want to copy those notes from yesterday. You're going to turn those in on the day of the test, which is going to be next Tuesday, 2/11. But we talked about the law of definite proportions. We talked about the law of multiple proportions. And I said the one way to keep them straight, law of definite proportions just deals with a single compound always having the same composition, meaning it's always made up of the same stuff in the same relative amounts. The second was the law of multiple proportions, which is actually what the back side of this worksheet is going to be about. That's when you're comparing more than one compound that contains the same elements. All right? So yesterday in the notes, we also talked about percentages, because when we do the law of definite proportions, we want to pay attention to, when we're looking at a compound, what percentage is this, what percentage is that, what percentage is this. So in number 1 here, table sugar is a compound known as sucrose. Okay? Sucrose is composed of the elements carbon, hydrogen, and oxygen. Analysis of 20 grams of sucrose from a bag of sugar finds that the sugar is composed of 8.44 grams of carbon, 1.30 grams of hydrogen, and 10.26 grams of oxygen. 1a, express as fractions the ratio of the mass of each element to the total mass of the sample. So whenever we're going to be doing percentages, I want you to remember this. Whenever we do percentages, the first question you want to ask yourself is, what is the total? So what is the total amount for this sample? Add all the numbers together, okay? 8.44 grams plus 1.30 grams plus 10.26 grams. It should add up to be 20 grams, which is what they told us we had, right? So we have 20 grams of sucrose. So if I write a fraction for each of these, I'll start with carbon. So it says out of that 20 grams, 8.44 grams is carbon. So I'm going to write 8.44 grams over 20.0 grams, and that's carbon. That's its fraction. Is there a question? For hydrogen, it says it's 1.30 grams. So I'm going to do 1.30 grams on top. And again, always put the total on the bottom. So the fraction for hydrogen would be 1.30 grams out of 20. And then for oxygen, it says 10.26 grams of the 20 is oxygen, so I'll do 10.26 grams over 20.0. And that's 8. Now I can just use these ratios to calculate the percent composition by mass of each element in the compound. Just basically, what are those percentages if I change those fractions to percentages? So those fractions kind of look like division problems, don't they? Because they pretty much are. So for percent carbon, I'm going to take 8.44 and I'm going to divide by 20. So I'll take my calculator out and I'll punch that in. 8.44 divided by 20. And so that comes out to be 0.422. Okay? Now that's not the percentage. That's the decimal. In order to make it a percentage, I got to multiply by 100%, or just move the decimal 2 to the right. So the percentage that is carbon is 42.2%. Do the same thing for hydrogen. So take 1.30, divide it by 20, do that in your calculator. and it will come out to be 0.065 as a decimal. Change that to a percentage by moving 2 to the right. Okay, and then oxygen is going to be 10.26 divided by 20, and that comes out to be 0.513, or 51.3%. So if all these numbers are accurate, their measurements, everything is accurate, then that means anytime I have sucrose, it's going to be 42.2% carbon, 6.5% hydrogen, 51.3% oxygen. Okay? If I had 1,000,000 grams of sucrose, what percentage of it would be oxygen? 51.3%. If I had 10 billion grams of sucrose, what percentage of it would be oxygen? 51.3. That's the law of definite proportions. If this is sucrose, if this compound is sucrose, it's always going to be in those same percentages. Okay? So if we go to number 2, it says a similar chemical analysis is performed on a 500-gram sample of the sugar isolated. So this is going to be our total on number 2, 500 grams. And they're taking this sugar from a sample of pure sugar cane. Analysis shows the sample contains 211 grams of carbon, 32.5 grams of hydrogen, and 256.5 grams of oxygen. So we're going to determine the percent composition by mass of each element in the sugar cane sample, which means I'm going to take each part, the carbon, which is 211, the 32.5 grams of hydrogen, and the 256.5 grams of oxygen, and I'm going to divide each of them by 500 to find the percentage. So for carbon, I'm going to take 211 grams and divide by 500. And if you put that into your calculator, you're going to find out that it comes out to 0.422 or 42.2%. And if you do hydrogen, and you take the 32.5 grams and divide that by 500 grams, that will actually come out to be 0.065 or 6.5%. And if I take the oxygen being 256.5 grams over 500, that actually comes out to be 0.513 or 51.3%. So for question B, 2B, could the sugar in this sample be sucrose? How many people think yes? Okay, everybody thinks yes. Good job. You're right. It is sucrose. Justify your answer. Justify your conclusion. The percentages are the same, right? Well, do you want to move up front? You want to see? You just want to complain about it? All right, so the percentages are the same. I would say it's sucrose. Sucrose is supposed to be 42.2% carbon. This sample is. Sucrose is supposed to be 6.5% hydrogen. So is this sample. Sucrose is supposed to be 51.3%. So is this. Looking at oxygen. All the percentages are the same. I'd say yes, it's sucrose. Everybody good with that? Can I erase that? Okay, so you guys are going to do 3 on your own. 3B doesn't necessarily have a wrong answer. I want to see what you think, what you put. But I'm going to do number 4 with you guys because it's a little trickier. But number 4 says we have a 1 gram sample of hydrogen. It's reacting completely with 19 grams of fluorine to form a compound of hydrogen and fluorine. All right. So again, we can see they're going to be in A, they're asking for the percent by mass. So again, the first question you want to ask yourself when you got to do a percentage, what's the total? So what is the total? If I take 1 gram of hydrogen and I combine it with 19 grams of fluorine, what's the total? 20 grams, right? So the total is going to be 20 grams. So if I want to find what percentage by mass of each element, I'm going to do hydrogen and fluorine. I'll start with hydrogen. And how much of that 20 grams was hydrogen? 1 gram, right? So I'm going to do 1 gram. That's the part that's hydrogen. And I'm going to divide that by the total, which is 20 grams. So 1 divided by 20 will come out to be 0.05 or 5%. So if 5% of it is hydrogen, what percentage should fluorine be? 95, because they should add up to 100, right? And we could do the math just to make sure. So out of that 20 grams, 19 grams were fluorine. Divide that by the total, 20 grams. And sure enough, if you do that, the answer comes out to be 0.95. Make that a percentage, 95%. So this compound would always, sorry, I'm writing it down here under number 5, just more space. This compound between hydrogen and fluorine, this particular compound, should always be that way, no matter how much of it you have. Should always be 5% hydrogen and 95% fluorine by mass. Okay? So then B says, what mass of hydrogen would be present in 50 grams, a 50-gram sample of this compound? So like I was just saying, we just did these percentages if we had 20 grams. But what if I had 100 grams? What percentage would be hydrogen? What percent would be hydrogen? 5%. If I have 1,000,000 grams of this compound, what percent would be hydrogen? 5%. Always going to be the same. So if I have 50 grams, 5% of it is going to be hydrogen. We just got to figure out a way to find 5% of 50. So the regular math, if you're trying to find 5% of 50, use the decimal for 5%, which is 0.05. So this is part B to number 4. Don't forget to do number 5 after I'm done. And so what I'm going to do on this is I'm just going to take that decimal for hydrogen and then multiply that by 50 grams. And that will equal 2.5 grams. So if I had 50 grams of it, 5% would be hydrogen. 5% of 50 is 2.5. So there would be 2.5 grams of hydrogen. Another way to think about that is, like I told you guys yesterday, if you have 50 grams, you know that hydrogen's 5%. What's 10% of 50? 5. Just move that decimal 1 spot back. And then 5% should be half of 10, right? What's half of 5? 2.5. Okay, so this whole front side is all about the law of definite proportions. This is our success criteria, is being able to explain this. Basically, you're always going to have the same percentages of each element in that particular compound. That's what it's really trying to say, just plain words. In your notes, I gave you kind of a more technical definition, but this is the idea. No matter how much you have of a compound, if it's that same compound, you're still going to have the same elements in the same percentages. Okay, so on this side, you guys got to do on your own 3 and 5. And then you're going to do the back side. Now, the back side is not law of definite proportions. You're not going to be doing percentages. You're going to be going back to the mass ratios of more than one compound. Okay, that's about the law of multiple proportions on the back. So I'll let you guys work through this. This is supposed to be done, fully completed for tomorrow at the beginning of class. We actually have a full hour this hour, so we should be able to get it done in class. I highly recommend you try to get it done in class because you're going to have some questions on the back side that you're going to want to ask me. All right?